Alright, next page. Oop, I hit the page down. Deduce the possible structure for the compound with the absorptions below. So narrow band around 3300. Oh, and at 2150. So these two tell us nice little triple bond. Does that take care of all my elements of sun saturation? It does. Takes care of 2 of my carbons, leaving 1 carbon behind, and 2 hydrogens. And a bromine. Oh, makes that kind of simple. Must have a bromine attached to that CH2, which is attached to the alkyne. Alright, first one of these with a nice little table there. So we're going to try to figure out what this is using just this data. Alright, first thing I'm going to do is figure out my elements of unsaturation. So 2 times that 5 plus 2 minus 10, we ignore the oxygens. We have 1 element of unsaturation. Is that right? 5, 12, yeah, 1 element. And I know from that it's a carbonyl, and it's actually awfully high. It probably is an ester. And I don't see anything else to do with the oxygen. There's no sign of an alcohol, so I'm going to go with an ester on this and see if we can make sense out of the remaining 4 carbons and 10 hydrogens. Alright, I'm going to keep it simple. That singlet with 3 hydrogens must be a CH3, and it's off on its own. And with it being shifted that high, it probably is right off that oxygen. I'm not going to put it there yet. I'm going to make sure these make sense first. So I have 3 hydrogens, 2 hydrogens, 2 hydrogens, and they're all split, so that implies they're together, and it does make sense. It's a multiplet between 2 triplets. The triplet is being split by a CH2, and that CH2 is also splitting this CH2, which is why we have a triplet and a triplet. And that's why this would be a multiplet. Alright, and this makes a lot of sense now. So our propyl group is attached to the left side of our ester, or the carbonyl side, and the O is connected to the CH3, which is why it's shifted up to 3.8. So we have this wonderful ester right there as a likely candidate. Alright, on 24, adding carbon as well. Alright, got 6 carbons, 10 hydrogens. I got 2 elements of unsaturation. Alright, that 3080 being higher than 3000 implies we have an alkene. And so does that. So those two together, definitely an alkene. The 1730, we have a carbonyl. Not enough there to tell for sure if it's an ester. Well, it can't be an ester. So it must be a ketone. Yeah, it'd have to be a ketone. Alright, so reason I know it's a ketone, I only have 1 oxygen, so it can't be an ester. It's not an aldehyde because I don't have a 2700 and a 2800, and it's not an amide because I don't have a nitrogen. So this has to be a ketone and an alkene. And that kind of confirms it. A 2210 singlet, that is definitely a ketone. Alright, got a lot of wonderful things here. These 3 and the 5s though, multiplet with 1 hydrogen, multiplet with 1 hydrogen, multiplet with hydrogen, that's our alkene, and it's got a bunch of hydrogens on it. That's what's making these 3 multiplets. Each of these 3 hydrogens is making that. And that corresponds over here. We have a doublet in the 150 to 100 range, which is a alkene carbon with a single hydrogen, and a triplet which is an alkene carbon with 2 hydrogens. So that correlates with this. Oh good, this won't be so bad. It was looking like it's going to be a mess. We know we got 2 of our pieces, and we know this is an end location. Alright, let's see if we can make sense out of the remaining things. Right. Oh, yeah, that's going to help. So 2.1, a singlet with 3 hydrogens is just a lone CH3. It's not near any other carbons with hydrogens. And then we have a triplet with 2 hydrogens and a multiplet with 2 hydrogens. Well, the 2 hydrogens, that's easy to explain. And that would give us all 6 of our carbons. And it does give us all of our hydrogens, so this must be our pieces. Alright, so the reason this is a triplet is because it's only being split by this thing. So on the other side must be that carbonyl. Alright, so I got this figured out now. That CH3 must be on one side of the carbonyl, which is why it's so deshielded. This triplet is also deshielded because it's near that carbonyl, giving us this other one. And the reason it's a multiplet is because it's connected to this vinyl group thing. Alright, got a lot of noise going on. I'm going to go up here and highlight what's giving me what. So these 2 hydrogens here giving me this. These get so close together, I am suspecting it's this guy and this guy. But it's, we have 2 hydrogens, so it's giving 2 separate peaks. Alright. Next one is this guy. It's got to be this doublet, and it's got to be this 5.8. Makes more sense that it would be more deshielded because it's in there. So yeah, I think that's right. I'm going to do my 210 now, get it out of the way. That is this guy. And it's a singlet because it doesn't have any hydrogens, but it's so shifted because of the oxygen double bonded to it. And then the other one that's kind of obvious is this singlet at 2.1, which has to be this thing because it's all nice and isolated. And on our carbon integral, it's going to be a quartet, also deshielded. Now, our most deshielded of these CH2s is also the most deshielded triplet in the carbon NMR, but it's only being split by just those 2, so it's the only one here that is a triplet. And then our final one got to be this guy, and it's right there. Alright, 25. C4H8. So I got 1 element. Yeah. And I don't have an ester. It's got to be a ketone again. Because I only have 1 oxygen, I don't have a nitrogen, and I also have a 210S. So that's definitely a ketone. Alright, my peaks, I have 3 hydrogen singlet, and I have 3 hydrogen triplet, and a 2 hydrogen quartet. That takes care of all my hydrogens, all my carbons. Yeah. Kind of nice when there's very few pieces. Alright, but we'll do the same thing we did above, and I'm going to highlight where I got these things. So that 1718 told me the carbonyl, so did the 210, and that's where I came up with that idea. Alright. And the next thing I identified was this singlet, and it is shifted. Didn't put it together right away. I just at first just actually kind of had it there. But along with that, partnered up with this 2-hydrogen quartet and 3-hydrogen triplet to give us this guy. And since that took care of all my pieces, I just had to put it together. Never really used much of my carbon NMR, but all these things are there. The two most shifted ones, or most de-shielded one, that quartet is got to be that CH3, and then this triplet and quartet are these guys. The reason it's a triplet is because the first one only has 2 hydrogens on it. So that's the triplet. Oops. How do we do it this way? That's the triplet. That's the quartet.